This next unit is about similarity or similar figures. Here we have two triangles, and we're saying that triangle ABC is similar. Notice the symbol is kind of like we had for congruent without the equal sign. So that's our similar symbol. We're saying triangle ABC is similar to triangle XYZ. And the way this is written, remember, just like we did with congruent figures, we're lining up these corresponding parts. A is corresponding to X, and B corresponds to Y, C corresponds to Z. So if these figures are similar, when we're talking about similar figures, there's two things going on. First of all, corresponding angles are congruent. So back to our figure here, we have A and X. We would know that those two angles must be congruent to one another. Likewise with B and Y, and then C and Z. So that's the first part. Similar figures, they have corresponding angles that are congruent. Now, where similarity and congruence are different, what we're really saying with similar figures, they're the same shape, but they're different sizes. Now, one thing about that when we're talking about those different sizes is that the corresponding sides must be proportional. So, if we know these figures are similar, let's say that this triangle here has sides that are 2, 3, and 4. And then in our corresponding triangle, let's say that we know that side XZ is 4. What we can do when we're talking about things that are proportional is we can set up a proportion to solve these. We need to make sure that we're lining up these corresponding sides. These two sides we know are corresponding. So when we set up our proportion, we would say 2 over 4 would be equal to, and then if I want to find, let's say I know BC, and I want to find this side here, it's opposite of angle X, we'll say that's side X. If I want to find side X, I know when I set up my proportion, I need to use a corresponding side. So 2 is to 4 as 3 is to X. And then we cross multiply and solve. 2 times X would be equal to 3 times 4. So now 2 times X is equal to 12. Divide both sides by 2. And we find that that side is equal to 6. Now, maybe you noticed, hey, if I just take 2 times 2, I get 4. We would say that that is our scale factor. All right, or this scale factor right here reduces 1 to 2. This triangle is twice as big as this one. So that would mean that this side, which corresponds here, we would also be able to find that out. Take it times 2. We would find that that side would be 8. So with this example, we are looking at these figures and we're asked, are these shapes similar? And then we have our two figures here that we're looking at. And if we look at these sides, we have 21, 30, 27, 30. And then over on this figure, we have 35, 50, 45, and 50. So as far as lining up these corresponding sides and seeing which parts would need to be then proportional, well, let's see, the shortest side on this trapezoid is 21, and the shortest side on this trapezoid would be 35. If these are similar, those would need to be corresponding parts. So to find out, are these figures similar, remember we said there's two things. We need congruent angles. So if we look back at our figure, we can see here the way it's marked, we have these two congruent angles adjacent to 21, two congruent angles adjacent to 35. Then on the others, these two are congruent, these two are congruent. So we do have congruent angles. So that first part, Yep, we're good to go there. Remember, we said our second part was corresponding sides proportional. So we already had the 21 and the 35 that we said were corresponding sides. So that would mean if 21 and 35 are corresponding, as we work our way around, here's our 30 and 30, that would correspond to the 50 and 50. And then the 27 and 45 would need to be corresponding as well. So what we're trying to find out is 21 over 35, is that equal to, that's a question mark, is that equal to 30 over 50? Those were two of the corresponding sides. Remember, we said here's the 30 and then here's a 50 that would need to be corresponding, and the other is 27 and 45. So what we're trying to find out is, are all these sides proportional to each other? Now, one thing I notice right here is that these are divisible by 7. 21, if I divide that by 7, I get 3. 35, if I divide that by 7, I get 5. So that reduces to 3 over 5. Well, the 30 and the 50, if I divide by 10, reduces to 3 over 5. And the 27 over 45, if I divide those by 9, 27 divided by 9 is 3, 45 divided by 9 is 5. They all reduce to 3/5. The other thing we could do is with our calculator, take 21 divided by 35, or take 30 divided by 50, or 27 divided by 45, or in this case, 3 divided by 5, and they would all go to the same decimal value of 0.6. That is showing us that they are proportional. Again, big thing we need to do when we're setting this up is we need to make sure that we're paying attention to our corresponding sides. So then, in our next example, same idea. Now we're asked, are these two figures similar? So as we set this up, what we're trying to look at is these corresponding sides. Again, we're dealing with trapezoids, and we have these congruent angles. All right, and then here's my short side is 19. Short side here is 23. Those would need to be corresponding. Then we have our 29 and 29. Here's a 25 and a 25. And then here's our 47, and this is also 47. So the longest side in this trapezoid and the longest side in this trapezoid are the same. So when we start talking about are they similar, in our first example, we found that they were all proportional. So then yes, those shapes would be similar. But in this figure, we have same side here, they're actually equal, whereas go to 19 and 23, those numbers are changing. So these would not be similar figures.